Hi, welcome to ChemTube channel. Today we are going to look at the Trial SPM Mrsm paper 2. We look into the section A, the structure questions. Question number 1, diagram shows the ingredient of a cake. So you can see the ingredients here: wheat flour, saturated fat, citric acid, corn syrup, caramel, lecithin, egg, margarine. So one of the ingredient in the cake is fats. Okay, so state the physical state of fats at room temperature. So what is the physical state? It should be the solid. Okay, if oil should be in the liquid form. Number 2, unsaturated fats can be converted to saturated fats through a reaction. So name the reaction. So it is hydrogenation or addition of hydrogen. This is a name for the reaction. C, citric acid is commonly used in daily life such as cake and biscuits. State the type of food additives and the function of the citric acid. So citric acid is under antioxidant. Its function is to slow down the oxidation of fats in the food or to prevent the oily or greasy food from becoming rancid. D, state another example of food additives in the cake here. Okay, given just now, like preservative, flavoring, stabilizers, emulsifiers, and dyes. So all can be found in the cake here. Question number 2, aspirin is used to reduce the fever and relieve mild and moderate pain. The structural formula of aspirin is shown in the diagrams. So state the meaning of the molecular formula. So the molecular formula shows the action number of atoms for each element. So you have to mention the action number of atoms of each elements in a compound or in a molecule. Okay. Next, write the molecular formula of aspirin. So it shows the action numbers, right? So we have to count how many carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 9 carbon. So you count one by one. Hydrogen, how many atoms, and then oxygen, how many atoms. So after you calculate, so it'll be C9. There is 9 carbon. Hydrogen, it has 8. Then oxygen, it has 4. Okay, so C9H8O4. Now state the type of particles in the aspirin. So type of particles here, it should be the molecules because there is no ions. Okay, in the aspirin. Number B. Okay. The following chemical equation represents the burning of aluminium with oxygen. So aluminium with oxygen to produce aluminium oxide. Give 2 information that can be interpreted from the chemical equation. So 2 information here, it can be qualitative, it can be quantitative information. So what you can give here will be like 4 mole of aluminium react with 3 mole of oxygen to produce 2 mole of aluminium oxide. So this one is a quantitative information. Or 4 aluminium atoms react with 3 oxygen molecules to produce 2 units of aluminium oxide. Okay, so these are the 2 information. Here it has the quantitative. Okay, quantitative means refer to quantity. For example, 4 mole, this one 3 mole, okay, this one 2 mole. For qualitative, okay, so qualitative here is aluminium. It's a reactants. Oxygen also reactants. Then aluminium oxide is the products. Okay. Question number 3. So what is the meaning of isotopes? Isotopes. So isotopes are atoms of the same elements. So you have to mention these terms. Atoms of the same elements with the same number of proton. Okay, same number of proton or proton number, but different nuclear number or different number of neutrons. Okay, B, draw the atomic structure of silicon 28. So atomic structure is including the electron arrangement and the number of protons and neutrons inside the nucleus. So the electron arrangement for the silicon is 14, so it be 2, 8, 4, right? Okay, so how many protons inside? So proton is 14, neutron is, so 28 minus 20, 28 minus 14, so is 14 also. Okay, so it has protons, 14 protons, 14 neutrons in the nucleus, so you have to draw this as well. Okay, yeah, you have to mention this under atomic structure. So if electron arrangement, so here in the nucleus, no need to mention about the protons and the neutrons, but in the atomic structure, you need to mention this. So 2 marks. C, the percentage of natural abundance for silicon 28, 29, and 30 is 92%, 5%, and 3% respectively. Calculate the relative atomic mass for the silicon. So this one we have the formula. Okay, so for relative atomic mass, so percentage times the nuclear number 28, so 92%. So silicon 29, 5%. Then silicon 30 is 3% only. So total it should be 100%. Okay, and divide by 100, so you'll get the relative atomic mass is 28. Isotopes are widely used in various fields. State one example of isotope used in medical field, Mrsm field. So you can write cobalt-60 for to treat the cancer patient, and then iodine-131, iodine-131. Okay, 131. For the thyroid patient, 131, not 130 or 131, or any other suitable isotopes.